So let's draw the resonance structures of these two molecules and then find what is the resonance hybrid, how it looked like, and the contribution of the different structures that we will be generating to the resonance hybrid. So first, I always want to put the lone pairs. I always do that at the beginning. Nitrogen, if you remember the structure of ammonia, for example, NH3, we know that the nitrogen is making 3 bonds and has 1 lone pair when it's formal 0 charge. So here you have 1, 2, 3 bonds, so I need a lone pair. Here my oxygen is going to have 2 lone pairs with 0 formal charge. And so now let's create the resonance structure. First pattern that I see is that I have 2 atoms and there's a double bond and a difference in electronegativity. So that is one pattern. We're going to move electrons. Always remember that's what you're doing in resonance. Move electrons over to the more electronegative atom. In doing so, let's do the drawing of the resonance structure. So now, now having formal positive here, I'm going to have the oxygen with 3 lone pairs, so it's formal negative. And I'm going to have the nitrogen here. Now, here we see another pattern. So here's a pattern 1, 2 atoms joined by a double bond, and there is a difference in electronegativity. Here, another pattern. A lone pair adjacent to a positive charge. So we can move those electrons over. And what you're saying essentially, that's sp2. What you can see here, that's sp2 hybridized. Only that now the p orbital is empty. Now, when we have that scenario and we can do this, we're going to say that the nitrogen is also sp2 hybridized. And so now we're forming another structure, and later we're going to be analyzing which one contributes more to the hybrid. But let's just draw it. And now what I have is still my oxygen is going to have 3 lone pairs, so it's that. And now nitrogen has 4 bonds, so that's formal positive charge. So no charge, and this has 2 charges plus octet is incomplete. And so this structure actually can be generated in, say, without drawing that, I could do, because the one in the center doesn't contribute much to the hybrid. So I could do this arrow and the other arrow and get over here. So these are my resonance structures. So let's see what contributes more to the hybrid and draw the hybrid. So here, no charges. Octet is complete at all the atoms. So that should be the most contributing. Next, we have these 2 structures. The structure in the center has a carbon where the octet is incomplete. So that contributes less to the hybrid. Here, you have octet complete in all the atoms. So you have, if you count for this carbon, you have 1, 2, 3, 4 bonds. So octet is complete. Same with nitrogen. In oxygen, for example, you have 2, 4, 6, 8 electrons. So octet complete everywhere, but we have charges. So if I am ranking them, I'm going to say that's the highest contributor. Then this is the second, and that's the third. So let's draw a resonance hybrid. And it's going to be essentially between structures 1 and 2. So let's draw that. When we do this, I'm going to draw here a partial double bond. Since in one of the structures I have a double bond, and here I don't. So I'm going to do this. And with the nitrogen, the same, I don't have a double bond, but here I do. So I'm going to put a dots here signifying double bond. And still remember, we don't move atoms in resonance structures, so stay in the same connectivity. Now, this structure will have contributes less, so, but still we're gonna have this delta negative and this delta positive. due to the contribution of that structure. So despite of the fact that we don't have charges in this one, but I did put like a small delta over there. So overall, you will have this partial charges in the hybrid, resonance hybrid. But this is the one that contributes the most. So let's do the structure in the bottom, the resonance structure for this anion that we have at the bottom. So now patterns, I'm gonna put my electrons. So if you have a carbon with a negative charge, yes, you will have two hydrogen atoms in a lone pair. That carbon is also sp2 hybridized. It is at an allylic position. Remember, these two positions are vinylic, so this is allylic. So I can move those electrons. I can delocalize those electrons, and I can do this. So I'm gonna draw my first resonance structure. And it's going to have, still have the double bond here. But now I'm going to have a lone pair, and that will be negatively charged. And now we're going to have a double bond here. Okay, so that's one structure. But still, I see that I have a lone pair at an allylic position relative to the double bond. So I can move those electrons over and put the charge at the end carbon. So that way I will give the following resonance structure. I'm gonna do it a little lower. So here I have this. So now I have my resonance structures. Notice that the first and the third are pretty much identical. So charge at the very end. So if you will, you can do this and you get exactly the same. So these two structures contribute the same to the hybrid. Now let's see if we have one structure that contributes more than another. Here you have a negatively charged, so sp2 hybridized charge on carbon. Here you also have a charge on a carbon. However, in this structure, if you think of the center one, that anion, you could do this or that, meaning delocalized to either side, and you will get this structure of that. So I'll say that that will contribute a little more than the other two. But now for the hybrid, the negative charge is now, if we number the atoms, this is atom 1, 2, 3, 4, and 5. Charge, partial negative charge is going to be in atoms 5, then 3, and then 1, as we see here. So let's draw the hybrid. So I'm going to just draw the sigma bond skeleton. And now this is going to be a partial double bond, as we see here, double bond, and here is known, so partial. And here I will have partial. In here, I have another partial double bond. One doesn't matter if I put the dots above or under. And here, I have also partial double bond everywhere. Next, what is that we need to do? Put the partial charges. We see that it is in carbon 5, so I'm going to put delta negative here. And it is in carbon 3 and in carbon 1. So that is my hybrid. Charge is always on a carbon, so about the same size, we're going to say, about the same contribution. Okay, so we're going to keep working more problems of this.